Good afternoon, sir. Myself, A. Adinarayana from Department of CSCA section. Today, I am here to talk about my CA2 assignment, and the topic is displaying elements in 2D arrays. Moving to next slide. Introduction to 2D arrays. A 2D array is a data structure that stores elements in a grid format. Each element in a 2D array is accessed using two indices, one for the row and one for the column. Understanding how to display elements in an array is essential for visualizing data effectively. And moving to next slide. Structure of 2D array. A 2D array can be visualized as a table with rows and columns. The size of a 2D array is defined by the number of rows and number of columns it contains that we allocated. Each element can be accessed using the syntax array of row column. Moving to next slide. Initializing a 2D array. In C programming, a 2D array can be initialized with specific values at the time of declaration. Some languages allow dynamic initialization where the array size can be defined at runtime. Proper initialization is crucial for avoiding undefined behavior when accessing array elements. Moving to next slide. Looping through 2D arrays. Nested loops are typically used to iterate through each element of a 2D array. The outer loop generally represents rows while the inner loop represents columns. This method allows for systematic to every element in the array. You can see at the side example it is given as per looping through 2D arrays. Moving to next slide. Displaying elements in row major order. Row major order means accessing elements row by row from left to right. This is the default storage order in many programming languages like C and C++. Displaying row major order can be accomplished with a straightforward nested loop structure. Moving to next slide. Displaying elements in column major order. And column major order means accessing elements column by column from top to bottom. This storage order is specifically used in languages like Fortran. A different nested loop structure is required to display elements in this order effectively. Moving to next slide. Formatting output for readability. Proper formatting helps make the displayed elements more understandable. Using tabs or spaces between elements can enhance visual clarity. At the side example, you can see that by giving spaces and tab spaces, the program can be easily understood and we can avoid confusion while giving the program. Consider adding borders and or labels to delineate rows and columns effectively. Moving to next slide. Common use cases for 2D arrays. 2D arrays are widely used in applications such as image processing and matrix operations. They are also utilized in game development for grid-based maps and level designs. 2D arrays are mostly used in matrix operations for addition, subtraction, multiplication operations. Understanding how to display 2D arrays is essential in these real world applications. Moving to next slide. Challenges in displaying 2D arrays. Handling large data sets can make displaying elements cumbersome and slow. Ensuring that the output remains user friendly requires careful consideration of formatting. Debugging array display issues can be complex due to multiple dimensions of data. Handling large data sets in Python is extremely difficult. Moving to next slide. And the conclusion. Mastering the display of 2D arrays is crucial for effective data representation. Always consider the context and purpose of display data to choose the right format. Regular practice and experimentation with different display techniques will enhance your skills. Feel free to expand on any of the slides or adjust the content as needed. Thank you for giving me this opportunity.